Hello friends, welcome to CareerClust. This is part 4 of our detailed learning of artificial intelligence and its topics. Today we are going to discuss about neural networks, its uses, advantages, disadvantages and how it works. This is very helpful for your understanding and interview preparation and revision. If you need any quick revision, refer our charts for a quick revision purpose. If you are new to our channel, please don't forget to subscribe. Please share your thoughts by commenting. Please watch till the end without skipping the video. What are neural networks? Computing systems inspired by the human brain that process information through connected neurons. Neural networks are mathematical models that learn to map inputs to outputs by adjusting connection strengths. They can approximate any function given enough neurons and training data, making them universal functions approximators. How it works? It is inspired by brain and connected nodes, pattern recognitions, self-learning, and parallel processing. Simply, neural networks learn from data, adapt to patterns, and improve over time by itself. Biological inspiration. So, as neural networks are inspired by human brain, how it is inspired by human brain and what are the comparisons and differences between neural networks and human brain? How the human brain maps to the artificial neurons. While artificial neurons are inspired by biology, they are simplified mathematical models. A biological neuron has thousands of connections and complex chemistry. An artificial neuron simply multiplies inputs by weights, sums them, and applies an activation function. This activation function plays a very important role in predicting the output. Yeah, we can compare with, on the left side we have a biological terminology and the right side artificial terminology. So in neural networks, on the biological terminology we call it as dendrites, and these dendrites are called as inputs. And we have cell body in the biological, and these are called as processing, that is activation function, and axon, that is called as output, and synapse, that is called as weights. These are mapping from biological neural networks to artificial neural networks. The human brain has around approximately 86 billion neurons. Modern AI models have billions of parameters that we call as artificial synapses. They are simply weights. Key components in the neural networks. These are also called as the building blocks of every neural network. They are: weights determine how much influence each input has on the output. Biases allow the network to shift its activation threshold. Together, they give the network the flexibility to learn complex decision boundaries that separate different classes of data. These are some key concepts. Neurons. What are the neurons? Basic processing units that receive inputs, apply computation, and produce outputs. And another terminology is weights. Weights determine the importance of each input learned during the training. Biases allow the model to shift to the activation function, add some flexibility. Activation functions. Activation functions introduce non-linearity, decide if a neuron should fire or not. Okay, we can learn all these things in detail in upcoming videos. Yeah, the formula is the generated output equal to activation function, that is we call it as a summation. It is multiplication of weight into input plus bias. That is, activation function is summation of weight into inputs plus bias. Types of neural networks. There are many types of neural networks. This is beyond the scope of understanding, but we can go very briefly on that one, but we can make another understanding video on this. Each neural network type is designed for specific data patterns. Feed-forward networks handle tabular data. CNNs exploit spatial relationships in images. RNNs capture temporal dependencies in the sequences. So CNNs can be used in images and videos, and RNNs can be used in the sequences or series. And transformers handle long-range dependencies through attention mechanism. What is feed-forward? So as we learned already in the deep learning, so it is going from input to hidden layers to outputs. So it is a one direction manner. Feed forward, data flows one direction, that is input to outputs. So it will be used in classification, regression. And CNN uses convolution to detect visual features. CNN can be used in images, video and spatial data. And RNN has memory, processes sequential data, so it can be used in text, speech, time series. And transformers, these are attention mechanisms, processes all at once, so it can be used in the parallel processing. It can be used by GPT, BERT, Claude and Gemini. And another type is GAN. So we can learn these things again in the future. Two networks compete generator versus discriminator. So it can be used in image generation or deepfake videos. Simply about transformers. Transformers have largely replaced RNNs for NLP, that is natural language processing task, due to parallel processings. What is the activation function? So this is very important in the deep learning and neural networks. They introduce non-linearity. Without them, the network is just a linear regression. Without activation functions, a neural network would just be a linear transformation. No matter how many layers you stack, it could only learn straight line relationships. Activation function introduce non-linearity, allowing networks to learn complex curve decision boundaries. So if there is no activation function, it will be like a straight line relationship. But if you want to make very complex decisions, it should be allowed in a non-linear function representation. So to make this non-linear representation, the activation functions helps. So it have some concepts in it. ReLU. So it works like max 0, x when hidden layer most common. So it is very fast, avoids vanishing gradient. And sigmoid function. The formula is 1 by 1 plus e power minus x. It is used in binary classification output. It means the output between 0 and 1. And another function is tan function, TANH. So the formula is e power x minus e power minus x by e power x plus e power minus x. It can be used when hidden layers are centers data. The output between -1 and 1. And another function is softmax function. The formula is e power xi by summation of e power xj. It can be used when multi-class classification input. So this is more into mathematics. So no need to learn all these things to understand neural networks functionality, but if you want to go very deep into it, this is required, and we will go deeper into this one in the upcoming videos. And the output of the softmax is output sums to 1 probabilities. Simply, ReLU, that is ReLU function, is the default choice for hidden layers in modern networks. Understanding the layers. So as I already mentioned, the neural networks can be in 3 different layers: input layer, output layer, and in between input and output, there is hidden layers. So each layer transforms data into a more useful representation. The depth of a neural network, number of hidden layers, that is depth is the number of hidden layers, determines its capacity to learn complex patterns. Shallow networks can learn simple patterns, while deep networks can learn hierarchical representation from low-level features to very high-level concepts. The layers are input layer, hidden layers, and output layer. So input layer is a single one, and hidden layer can be n number of layers, and one last output layer. So what is the functionality of input layer? Receives raw features, that is pixels, words, numbers, that is one neuron per feature. And hidden layers, so hidden layers can be n number of layers, and one layer output will be consumed as input for another layer. So it extracts increasingly complex patterns. If it is having more layers, then deeper understanding. So it can have n number of layers. And the finally output layer. This is produces final predictions or classifications. Neurons equal to number of classes. Simply, hidden layers learns edges, shapes, objects, and concepts. This is increasing abstraction, and the predictions done in the hidden layers are kind of black box decisions. So we cannot predict and we cannot understand what is going on in the hidden layers, but according to the trainings and understanding, it will predict the outputs. How neural network learns? So this is very important. The training loop repeated thousands of times. So as I already mentioned, we provide some data to the network, the neural networks, and that makes the patterns out of it. And that learns from itself. It predicts some value and it compares with the actual output, and it itself learns. The gradient tells us the direction and magnitude of change needed for each weight. Gradient descent follows this signal to minimize the loss function. Modern optimizers like Adam adapt the learning rate per parameter, making training faster and more stable. So in the learning process, there are some features. Forward pass. In the forward pass, input flows through network to produce the prediction. This is a kind of forward propagation. And loss calculations. It will come into picture when the predicted value is not actual value. Measures how wrong the prediction is. That is loss function. So for example, the prediction value is 2 and the actual value is 5. It calculates the difference, the loss function, how much it is wrong. And back propagation. So back propagations comes into picture when there is a loss calculation, or when the loss function comes into picture, the back propagation works. So it will again go back to the input layer from output layer, and it will recalculate with the loss functions and applying some bias or activation functions to it. How it works? Calculate gradients, how much each weight contributed to error. And weight update. Weight is nothing but a kind of constant. So optimizers adjust weights to reduce the loss, that is gradient descent. This loop repeats for every batch in every epoch until convergence. Convolution neural networks specialized for visual data, images, and videos, that is CNNs. Convolutional layers apply small filters called as kernels that slide across the image, detecting local patterns like edges and textures. Pooling layers reduce spatial dimensions while keeping important features. This hierarchical feature extraction is what makes CNNs2 effective for visual tasks. It contains convolution. What is convolution? Slides a filter over the image to detect features, that is edges, textures, or shapes. And pooling. This is another concept in it. What is pooling? Reduces spatial size, keeps important information, discards noise, that is max pooling. Feature maps. Output of convolution, that is highlights where features are detected. And fully connected. Final layers that classify based on extracted features. Real world examples are, it classifies what is cat versus dog, and digit recognition, some tumor detection in the medical field, and object detection. Transformers, transformers and attention. The architecture behind every major LLM today, they are transformers and attention. The key innovation of transformers is self-attention. Each element in the input can directly attend to every other element, regardless of the distance. This solves the long-range dependency problem that plagued RNNs and enabled massive parallelization during the training. Self-attention. What is self-attention? Each word looks at every other word to understand context and relationships. Parallel processing processes all tokens simultaneously, unlike RNNs, which go one at a time. So, in transformers that do a parallel processing. And positional encoding, it adds positions info since attention has no inherent order. So, we can learn very detailed about all these things in the future. Some powered by transformers. GPT-4 handled by OpenAI, Claude Anthropic, Gemini Google, Bet Google, and Llama Meta. So transformers are being used in these models. Attention is all you need. The future of neural networks. Where neural networks are heading next. Neural networks are becoming more efficient, more capable, and more acceptable. Techniques like quantization and pruning make large models run on phones. New architectures like Mamba Challenge, Transformers, Dominance. The boundary between AI and human intelligence continues to blur. So uses of some future of neural networks is AGI, that is artificial general intelligence. This is human level reasoning across all domains. So if AGI comes into picture, this takes very quick and very accurate decisions, same like humans. And next is neuromorphic computing, that is hardware that mimics brain structure, ultra efficient neural processing. Another one is edge AI, neural networks running on phones, internet of things devices, no cloud needed. So this edge AI runs on the phone or IoTs. IoTs means the appliances usually we use in home. Multi-model models. A single model that sees, hears, reads, and generates like GPT-4V. We are in the early days of neural networks, the best yet to come. I hope you understand neural network. This is having some complex terminology. This is very deep understanding of the neural networks. Please continue watching our upcoming videos to understand this best. Please like, share and subscribe. Thank you for watching.